We all know that digital computers have revolutionized every aspect of our lives, from how we communicate to how we explore the universe. But the arrival of quantum computers could usher in changes far more profound, reshaping not just technology but our very understanding of reality itself. Throughout human history, the quest to understand the nature of reality has been a cornerstone of science, philosophy, and spirituality. Questions like, what is the universe made of? How do the laws of physics govern it? And the most profound of all, does reality exist as we perceive it, or is it a construct of our minds? Have guided countless thinkers. Recently, a revolutionary development in quantum computing has reignited these existential inquiries. Scientists have created a new quantum chip so advanced that it challenges the very foundation of our understanding of existence. This discovery's implications are nothing short of paradigm-shifting. According to the data generated by this quantum chip, the universe as we know it may not actually exist in a definitive physical sense. Let's start with the basics. Quantum mechanics is the branch of physics that deals with the behavior of particles at the smallest scales, atoms and subatomic particles. At these scales, the familiar rules of classical physics break down. Instead, particles exhibit behaviors that seem almost magical. They can exist in multiple states simultaneously, a phenomenon known as superposition. They can also instantaneously affect each other over vast distances, a phenomenon called entanglement. These strange behaviors have puzzled scientists for decades, challenging our very understanding of what it means for something to exist. The creation of this new quantum chip has expanded our understanding of these phenomena to unprecedented levels. Operating at revolutionary speeds and capable of handling vastly more qubits than its predecessors, this chip allows scientists to simulate quantum systems with precision previously thought impossible. The results of these simulations have led to an astonishing conclusion: the universe may not have a concrete physical foundation. To understand why, we must delve into one of quantum mechanics' most debated interpretations, the idea that reality is observer-dependent. This concept arises from the famous double-slit experiment. When particles like electrons are shot at a barrier with two slits, they behave like waves, creating an interference pattern on a screen. However, when a detector is placed at the slits to observe which path the particles take, the interference pattern vanishes. The particles behave like particles again. This suggests that the very act of observation determines the particles' behavior. In other words, particles don't have definite properties until they are observed. Instead, they exist in a state of probability, a mathematical description of all possible states they could occupy. It's as though reality itself doesn't solidify until a conscious observer interacts with it. Now, let's connect this idea to the breakthrough in quantum computing. The new quantum chip has enabled scientists to simulate quantum systems on a massive scale. One key experiment involved simulating particle behavior in a universe governed solely by quantum mechanics. The results were astonishing. The simulations suggested that particles exhibit classical physical properties only when observed by an external system. Without observation, the universe exists as a mathematical abstraction, a cloud of probabilities with no definitive reality. This aligns with the philosophical concept of non-realism, which posits that the physical world is not objectively real. Instead, it's a kind of shared illusion, created by our consciousness interacting with the quantum fabric of reality. These ideas have profound implications for our understanding of existence. If reality isn't objectively real, then what does it mean to say that something exists? To answer this, we must confront the nature of consciousness itself. Is consciousness merely a product of the brain, or is it something more fundamental, a cornerstone of the universe? The data from the quantum chip hints at the latter. Simulations revealed that in a universe without conscious observers, quantum systems never collapse into a definitive state. They remain in superposition, existing in a liminal state where all possibilities coexist. This strongly suggests that consciousness isn't just an emergent property of physical systems like the brain. Instead, it appears to play a fundamental role in shaping reality itself. Some physicists have proposed that consciousness may be the only thing that truly exists, echoing ancient philosophical ideas like idealism. This perspective holds that reality is fundamentally mental rather than physical, a kind of shared dream created by countless conscious minds. This notion may seem far-fetched, but it's supported by some of quantum mechanics' most puzzling phenomena. For example, quantum entanglement demonstrates that particles can influence each other instantaneously, regardless of distance. This has led some scientists to propose that the universe is fundamentally interconnected, with all particles forming part of a single, unified whole. The new quantum chip supports this idea by simulating entangled particles on an unprecedented scale. The findings suggest that the universe isn't a collection of separate objects interacting through physical forces. Instead, it's a seamless web of relationships, where distinctions like here and there or now and then break down. This revelation doesn't mean reality is fake or unimportant. On the contrary, it shows that reality is far more intricate and extraordinary than we ever imagined. One of the most profound implications of this discovery concerns free will. In a classical deterministic universe, every event is the inevitable result of preceding causes. But in a quantum universe, the future is not fixed. It exists as a range of probabilities, influenced by the choices we make as conscious observers. This suggests that free will may not be an illusion, as some scientists have argued. Instead, it could be a fundamental aspect of reality, a means for consciousness to shape the universe's unfolding. The implications extend beyond philosophy. The discovery that the universe isn't objectively real challenges our understanding of artificial intelligence. Could a sufficiently advanced AI develop its own form of consciousness, becoming a participant in the creation of reality? The quantum chip has also opened doors to revolutionary technologies. From instantaneous quantum communication to advanced medical devices, the possibilities are grounded in the principles underlying this breakthrough. Yet, these advancements come with risks. How do we ensure these technologies are used ethically? How do we navigate the moral challenges of manipulating a reality that's far more interconnected than we imagined? The quantum chip's true legacy may not lie in the answers it provides but in the questions it forces us to ask. It reminds us that the quest to understand reality is not just a scientific endeavor but a profoundly human one. The journey into the quantum frontier has just begun, and it promises to reshape our understanding of existence, free will, and our place in the cosmos.